When we think about path control mechanisms, the first thing that would typically come to mind is policy-based routing. And policy-based routing and static routes have a lot in common. They say, if this is what's going on, do this. Static routes, if it's this destination, do this. If it's policy-based routing, if it's any of these combinations, do this. It's static, right? But that can get us into issues where we lose the ability to maybe go to a backup link. Let's say that ISP1 is experiencing a problem and they have lost internet routes. Well, let's say they are in a situation where they've got some serious problems going on and the routing infrastructure of ISP1 is no longer there. But I still have connectivity to ISP1. If I have static routing or policy-based routing set traditionally, I am going to continue to route traffic through the primary. What we have to do is we have to conditionalize our static routing environment or our PBR environment so that we can watch for things as they go down. IP SLA allows us to track objects. And we track objects which are like probes. And in fact, a probe is the right term for some of the constructs inside of IP SLA. And we can set up our PBR or static route to watch for those things. And we watch for them and further add dependencies to our static routed environment or our PBR environment. So here's how we do it. We set up these little things called probes. And now I'm going to probe into ISP1. I'm going to be looking for maybe a few IP addresses that I know should be reachable, that are maybe public, and I'm going to test those. Think of this as an ongoing ping. And then I track that, and then I tie it to a static route. And if my pings start to fail, I drop maybe that static route, and I fail over to my backup. That is the beauty of IP SLA for path control.